Good morning, students. How are you today? Alhamdulillah, I'm fine too. Alright, before we start our lesson, let's pray first. Shall we? Alright, thank you. Okay, today we will talk about hydrocarbons, especially alkane. But before we start, could you please see on the screen? Okay, what do you see on the screen? A tree, a sheep, a cow, and a caterpillar. Yes. What do all these objects have in common? What do all these objects have in common? Animal? There is tree. What do all these objects have in common? Yes, they are living. They are living things. Or we can say that they are all organic matters. What is organic matter? What is in your mind if you heard about organic? What is organic? What is in your mind? Maybe vegetable? Or organic food? Organic fertilizer? Yes, they're all organic. Okay, but before we talk further, I will show you our lesson objectives. So today, we will try to learn about the definitions and physical properties of alkane. Alkane is one of organic chemistry. So organic chemistry is a part of chemistry that study about organic compounds. Organic compounds is compounds that contain carbon atoms compound. So why carbon containing compounds are special? Why chemists learn about these carbon compounds specifically in organic chemistry? Because carbon can form four bonds that are strong. So because it has four electron valence, it can form four bonds. So one carbon atom can bond with other carbon atoms, or it also can bond with other hydrogen atoms to form one type of compounds called hydrocarbons. Okay, for example, on the screen you can see a compound that consists of carbon-carbon chains and also hydrogen atoms. So this compound is part of alkanes. The name of the compound is butane. Okay, so butane is a hydrocarbon. Why this compound called hydrocarbons? Because it consists of hydrogen and carbon. If the compounds have other atoms, for example, butanol has other atom, which is oxygen. So butanol is not a hydrocarbon, it's an alcohol. We will talk about alcohol later. Okay, so hydrocarbons actually also have several groups: alkanes group, alkenes group, and also alkynes. But for today, we will only talk about alkanes. The most simple compound of alkane group is methane, CH4. It has one carbon and four hydrogen. The other compounds are ethane, C2H6, propane, C3H8, and butane, C4H10. Okay, for now, let's see these four compounds. So if we see the empirical formula, if we see the molecular formula, we can see that each compound has one C and two H differences. So from methane to ethane, from ethane to propane, from propane to butane, it has CH2 difference. We call this as homologous series. So this homologous series, they have similar properties and they can react in similar way, and they also have a general formula. So the general formula of these compounds are the same, which is CnH2n+2. So let's check for methane, CH4. Methane has one carbon and 2n+2 hydrogen, right? One carbon and 1 times 2 or 2 times 1 plus 2 hydrogen. So equal 4 hydrogen. For ethane, it has 2 carbon and 2 times 2 plus 2 hydrogen equal 6. So ethane has a molecular formula C2H6. Propane also like that. So it has 3 carbon. Therefore, the number of hydrogen is 3 times 2 plus 2 equal 8. And also butane also has C4 and H10. The number of H is 2n+2. Okay, let's see other example. Hexane. Hexane is also an alkene. It has 6 carbon atoms. What is its molecular formula? Okay, because the number of carbon is 6, so we can calculate the number of hydrogen is 12 plus 2. 12 from 2n. The number of n is 6, so 2 times 6 is 12. 12 plus 2 equals 14. So the molecular formula of hexane is C6H14. Okay, let's talk about these compounds' physical properties. So for alkenes, here's the example: methane, ethane, propane, and butane. The trend is the higher the number of carbon, so the higher the boiling point is. So the boiling point increase when the number of carbon atom also increase. So in room temperature, methane, ethane, propane, and butane are gases. But if we have a longer carbon chain, for example, heptane here, heptane has 7 carbon atoms. So at room temperature, this compound, this heptane, is a liquid because the boiling point increase. And how about the longer compounds? For example, this compound, it has more than 20 carbon atoms, so it can be solid. So the form of the compounds at room temperature is depend on the number of carbon atom. It can be gas, it can be a liquid, it also can be solid. How about the volatility? So because the low boiling point, alkene that has 1, 2, 3, 4 carbon atom is gases, and it's also volatile. Volatile means it's evaporate more easily. as for the longer, much longer compound, it will be more viscose like honey. It's viscose. And generally, alkane are flammable, so it's easily burned. That's why alkane compounds are primary components of LPG, liquefied petroleum gas. So like we use at home for cooking. So the LPG gas is mainly consists of propane and butane. And fun fact, propane and butane are odorless, so it has no odor at all. But why? If we have a leakage LPG at home, like the gases is leaking, there is a bad smell, right? Nah, that's because of the additive. So the manufacturer, they added the additive, the smelly additive. So if there is a leakage of the LPG gas, we will notice instantly. So we can have like some preventions before explosion and other accident. So the smells, the smelly compound is an additive, not originally from the gases itself. So any questions? Okay, if there is no questions, here's the homework. I will share the file in our Google Drive, and please fill out the tables, and also find some products containing this one must be alkane, not alkene. Okay, containing alkane you find in daily life. Okay, and submit in the next meeting. Okay, if there is no question, I will end this meeting. Thank you for your attention, and see you next week.